Hello everyone, in this video I'll be discussing about types of scheduling algorithms and their advantages and disadvantages in operating system. Here I'll be explaining about scheduling algorithms and their importance in computer systems, overview of different types of scheduling algorithms and advantages and disadvantages of each algorithm. Characteristics of algorithm are well-defined inputs, well-defined outputs, finiteness, feasible, language independent. Here, first come, first served, FCFS, which means FCFS schedules processes in the order they arrive. It is simple and easy to implement, may result in poor response time and low throughput. First come, first served. Schedule the process according to their arrival order, means to the ready queue. Also called as FIFO, which means first in, first out. You can see the example over here. Shortest job next, SJN, which means it schedules the shortest job first, minimizes average waiting time, and it is difficult to predict job lengths, leading to the potential starvation for longer jobs. Priority scheduling. Priority scheduling assigns priority levels to process, and it allows for priority based resource allocation and may result in low priority process suffering from starvation. There are two types in priority scheduling, which are primitive scheduling and non-primitive scheduling. Round robin. Round robin assigns a fixed time slice to the each process and fairly allocates CPU time along processes. High context switching, overhead and potential for inefficiency. You can see uh, burst time and the processors. The gain chart for the Robin scheduling will be like this. Multi-level queue scheduling. Multi-level queue scheduling divides processes into multiple queues based on priority. It provides different priority levels for different types of processes. And multi-level queue scheduling is complex to implement and manage. Multi-level queue scheduling, its hierarchy goes as from lowest priority to highest priority. Student process and batch process and then interactive editing process, interactive process and then at last system process. Here the lowest priority is student process and the highest priority is system process. Like this the multi-queue scheduling will be executed. Multi-level feedback queue scheduling. Multi-level feedback queue scheduling allows the processes to move between different queues based on their behavior, and it provides flexibility to handle different type of processes and requires fine tuning of parameters for optimal performance. Multi-level queue and multi-level feedback queue. You can see the diagram which shows the multi-level feedback queue. System process from ready queue 1 and interactive process or round robin for ready queue 2, and at the last batch process which is ready queue 3, which will be at all connected to the processor. Shortest remaining time. Shortest remaining time schedules the process with the shortest remaining burst time. It minimizes response time and improves the throughput. It requires knowledge of burst time in advance, which may not always be available. Shortest remaining time scheduling. Shortest remaining time scheduling, uh, which preemptive version of SPF. It is shorter arriving process preempt a running process. Very large variance of response times long process wait even longer than under SPF, and not always optimal. Short incoming processes can preempt a running process that is near completion. Lottery scheduling. Lottery scheduling assigns tickets to process and selects a winner randomly. It provides fairness and allows for resource allocation based on probabilities. It may result in inefficient resource utilization if not properly managed. You can see the way in which way lottery scheduling will be taken place. Multi-level queue. It is ready queue is partitioned into separate queues. They are foreground, which means interactive, background means batch. Each queue has its own scheduling algorithm. Foreground has RR means round robin. Background has FCFS. Scheduling must be done between the queues, which is fixed priority scheduling, that is, serve all for foreground then from background. Possibility of starvation. Time slice. Each queue gets a certain amount of CPU time, which it can schedule among its processes, that is 80% of the foreground in round robin, 20% of background in FCFS. Conclusion. We discussed about recap of the different scheduling algorithms, and each algorithm has its own advantage and disadvantages. Selection of a scheduling algorithm depends on a specific requirements and constraints of the system.